Mm. Sorry guys, I'm just trying to set up my stream for the first time on this computer. Just making sure everything's working. Alright. If anyone's watching, please leave any feedback you might have on audio quality, volume, anything like that. Alright. Cool. That working. Oh, we got GitHub logged in. Everything seems to be working on this new setup. Let's just run lazy git. Oh, what? Oh, that's right. I haven't committed this repository yet. Yeah, sure. Fatal, unable to auto detect email address. Git global. If I set that again, git global.name emails equal to let's just go to SSH, see what's here. Sorry, I'm just gonna log into some private stuff on the screen. I didn't realize I didn't have this before the stream. I'm just gonna blank the screen for a second. Let's see. All right, how do I? I'm just trying to hide my actual email address for this account, and I'll just copy the temporary, the anonymous one that GitHub auto generates for you and use that. Okay, that should be good. Let's see. Okay, let's ask ChatGPT how do I set my, nah, screw it, let's just Google it. Git set global email username. Git config -- global user.name. Cool. Git config global user.email. There's my public GitHub email. Should be good. And let's set the name as well to, what is my username on Git? Let's see. Yeah, it's just on the storm. Should be good. That should be good. Just go with that. I don't like using uppercase, but I want to avoid using the underscore. Doesn't really matter though. Okay, let's see if it works now. Yeah, there we go. Cool. Right. Coolio. I'll push this up to my account later on, my GitHub account. For now, we'll just work locally for the stream. Yeah, cool. Let's open Helix. Open up code. Get started. So I don't have any views yet, but I'll just explain anyways for anyone watching in the future. So I'm currently working on I would say a game engine, but it's more of just a small library of tools to help you make games. But I am technically, I guess you could call what I'm doing a game engine. It's a framework to help you write games. And basically the whole point of it is it's going to be a tool people can use to quickly prototype game ideas. Trying to get rid of that traditional friction or overhead that you have when you try to quickly iterate on ideas while you're writing games. Just get rid of all the bloat possible and make it as easy as possible to get something showing on the screen, handling user input, and getting some basic UI up and running. That's pretty much the goal here. So we're not aiming to add any insane features. We want to keep it simple and clean and easy to understand and use. So for now, we don't have much. I recently started learning how to do some graphics programming. I've tried in the past, but I'm kind of trying to learn it again. And yeah, I'm still struggling with the fundamentals from time to time, but we're using Winner to create a window, and the way I understand it is that's how this hooks into your operating system, and your operating sends events to your Winner session, your Windows session, and these events get forwarded to your to your window from the operating system, and you can then kind of pipe it through to whatever you want, or you can handle it here directly. So we create a window, And then once we have a window, we pass the window handle, a window pointer to web GPU, which is the library we're using. I'll just show you over here. And that's just an abstraction over whatever graphics library the platform you're running your app on can handle or has available. And through this API, the abstract API that when it provides, you can draw stuff to the screen. So far, we only have basic images being drawn to the screen. So we load textures and we can let our user create what's called a sprite. Let me see. And the sprite just references a texture that it wants drawn, and then it describes how that texture should be drawn. And then with Web GPU, we try to draw the user sprites in an efficient way, and we just inside a shader apply all the properties that they want applied to their sprite, like where do we want the text drawn on the screen, what's its rotation, what's its scale, what's its color. And later we'll be adding more stuff to this probably down the line. Sure, I'm probably missing some things you'd come to expect in a lot of game engines or rendering frameworks. But yeah, that's what we have so far. And yeah, so we're trying to get that basic drawing up and going for people to obviously start making their games. I'm thinking I might add some, for the final version, add some primitive drawings as well. So generate like circles and squares or rectangles and a few other polygons, and also provide like where to draw lines and stuff like that. And that should be all you need to really need to prototype game ideas. I am adding sprites as well though, even though you could probably say that that's not necessary if you just want to prototype ideas. But sometimes it is necessary to draw like gameplay, like combat indicators or weird stuff with sprites. It's just a lot easier than trying to build up what you want to draw from primitives. So there's that. And also, if you want to maybe use some pictures, some art assets to make your prototype feel a bit more fun to work on, I kind of want that option, but also I don't want it to what's the word? I was gonna say betray, but yeah, as long as it doesn't impede on the idea of the actual game engine just being for prototyping and being like simple and easier to use. Cool. So on rendering side, that's kind of what we're aiming for with this engine or this tool. And then I might add, I'm trying to add audio at the moment, just so you have some basic audio capabilities in case you somehow need audio for your product or for your prototype. And after audio, of course I want to add some basic UI. Now for the UI, it's a bit more complicated. Making a custom UI framework for something like this can be easy, but it can also be very hard depending on how hard you want to make it. So I think for for the UI, for now, I'm just gonna drop in something like eGUI and have people use that. That technically is like, it's already a UI library made for the exact same purpose as I'm making this engine, like quickly prototyping and debugging instead of worrying about looks and getting things like making high-end UIs. But in the future, I do want to delve into creating my own UI library because I think it could be even simpler and even more expressive than something like eGUI. And I just don't like the idea of immediate mode UI. I don't mind it too much, but it's I think it could be, your code could look a lot cleaner without it if you have a UI with state. And yeah, but so that's pretty much what we're trying to make. Something where you can you can prototype your games, get stuff drawn on the screen really quickly, and have some basic spatial audio, and get some like very simple UI going for, obviously for user input, but also for debugging and stuff like that. So we want it to be really easy to get stuff on the screen with minimal code. I don't want a bunch of glue code between the user's idea, the user's game, and the engine. So the engine should be seen as just kind of a front end for your game. And you kind of want to think about writing your game as a completely headless game, in a way completely unaware of how it is interfacing between the game and the user. Kind of abstract that away. So, and then what you want to do is you want to take your headless game, once you've experimented, iterated a lot, come up with an idea that you really like, played around with game mechanics, tweak things, balance things, just go crazy. That's the whole point of this, is to provide a tool for you to focus on just your gameplay and your game mechanics and how your systems work and how your code look, architecture works and all that stuff. And then later on migrate that part of your project, the core of your game. You could say your game logic and game state. Move that over to a better engine for that if you want to make something professional and publish that. So you could take the code, move it over to something like Godot, and use the Godot Rust bridge or the Godot Rust extension to integrate your game with Godot as a front end. And then hopefully at that point you've already worked out all the wrinkles in your product. You've been iterating fast. You have something, you know what you want to do. And you can at that point know that all the major problems in all the bugs in your code, all the design decisions, all those things. At that point, you hopefully know what your game, like you almost in a way done with the logic of your game, the gameplay. And then you can just focus on creating nice UI, creating nice visuals, good audio, and creating a really polished user experience. And obviously create the actual like art for your game and stuff like that. After you've already figured out what your game is going to be, and you've already actually implemented and written the code that runs your game, kind of like your own, the thing that powers your game, all the game logic and the game state and all that stuff. So that's the purpose of this. It's to provide a, I guess another way to put it is it provides a medium for people to grow their games in, the game ideas. I guess you could be a bit more specific and say to grow their game mechanics in, kind of like a incubator or something. And then the idea is to, after that, migrate that out and go to something more capable for, in terms of like what was I gonna say, platform support, graphics, audio, and integration with things like the Play Store, Steam, all those things. Hopefully you can add all those later in a more suitable game engine. But over here, the idea is to actually figure out what you want to make. But yeah, that's it. So that's probably the first time I've explained it, so that was a very long explanation, but hopefully whoever, if you heard that, hopefully you kind of get an idea of what I'm trying to do here. And yeah, so let's jump in and start messing with our audio, because last time I started working on this, but it's like I just quickly sat down for like 40 minutes and like looked up a bit about how to get audio working. Looked up, I mean, basically just asked ChatGPT, because I have no clue how audio works. It seems like it should be very simple, but apparently it's not simple. Apparently different platforms handle audio very differently. Audio's usually something that should happen asynchronously. You can't like play an audio play an audio clip and wait for it to finish before you run the rest of your code. So you kind of want to do that asynchronously. But luckily for us, of course there would be a couple of libraries to choose from that abstracts the most difficult parts of doing audio away for us. The only problem I have is I started using a library called, what's it called? Oh, Kira. So I started using Kira, and I just I don't know why I didn't think about it, but I didn't make sure to check what platforms it supports, because it would be nice if I could support building for Android as well, in case you ever want to use this engine for developing a mobile game. It's hard because WebGPU doesn't WebGPU does, but I think, but when it doesn't officially support Android and iOS, but you can get it working. So if I could get the audio to work to be platform agnostic as well, then in theory, with a bit of elbow grease, the user should be able to get, at least on their device, should be able to get like the game up and running using this game engine. And even though it wouldn't be suitable for, like, even though it wouldn't have good support, hopefully you could get it good enough to where you could still use this engine for prototyping on a mobile device. And then, of course, later move on to something more suitable like Godot. that has full support for all platforms that you would want to publish to, and has fancy support for different types of controllers and inputs and all that. But yeah, so unfortunately, I realized after I started using this, that Kira doesn't seem to support mobile devices, Android and iOS. Let me see. Let's go to the GitHub backend agnostic library to create expensive audio for games. So that's exactly what we're looking for, and it's meant for games. So that's why I started using it. But then at some point, I saw that yeah, meant for desktop applications. So that's kind of sad, because I was under the impression that it kind of worked on everything. I didn't read any further, which is kind of on me, I guess. So we might throw away all this code at some point and move to something else that has better support for mobile, and then hopefully we could make the engine a bit more friendly for mobile platforms, and desktop as well. But yeah, for now, I have the basics I like working, I think. Well, I started implementing the basics, and I'm just gonna continue, and then later on move over to something else. At the moment, I just want to get a very rough, unfinished version of the engine working, even though it wouldn't have the same API or architecture, probably not even the same architecture in the final result. Cool. Okay. So let's get started. So last time, this is what I made. As you can see, users should be able to load sounds, unload sounds, create a listener, destroy a listener, and play a sound. And what I realized is that when you play a sound with Kira, it returns a sound handle for you, and you use that to actually control how the sound is played back. So a sound is not the sound data. It's kind of like synonymous to how textures and sprites are compared to each other. They're not the same thing. Like in a game engine, your texture is the actual image data that you have in memory, and a sprite is just kind of like an instance of that image that you want to render somewhere. But you could have 1,000 sprites using the same image. Same thing for sounds, of course. You have your actual sound data that you load into memory, and that's your sound file. And which my audio went off. Oh no, it looks good. Anyways, so what was I was saying? Sorry. So you could of course also have like 100 sounds playing at the same time, all using the same sound like data. So the actual sound you get back from Kira, it returns a sound handle, which is safe to give over to the user, and from here they can control the sound, and you could play the same sound data, create 5 sounds playing from that, and play each of them differently. Like play the one at double speed, play the other one at half volume, increase the pitch on another one, and stop the audio early halfway on another one. So that's what the sound handle is. As you can see, we got a few. Oh, there's not too much they could do, but yeah, they could do change the position of the sound, set the loop region, loop a small portion of the sound over and over, play, resume, pause and resume, resume at a certain point in the sound, stop, move up to a certain point in the sound, and seek by, move forward a certain amount. Okay. So there's some basic stuff you could already do with sounds in the engine. I'm just exporting the actual sound handle from Kira. Um, so I that's great because this is temporary code and I don't have to wrap all this in my own API. I could just return this for now. Cool. Okay, so we have sounds that you can play, but you also need listeners that decide how you're gonna, of course, hear the sounds. Because we want spatial sounds, even though we're making a 2D engine, you still want to use that like feature, like provide that feature for the users of the engine if you can. Mm, cool. So when you created a listener, this is what I wanted to change last time. So currently I take ownership of the listener and I create an ID for it and I pass that over to the user. And if they want to change the listener at any point, like move it around in the scene or whatever, move it around in the game world, um, they have to. I currently have to provide for safety. I wanted to take control of the listener and let them interact with that through my API via a ID. But I realized that the listener also comes with a like everything I already need. It comes with a listener handle and there's no need to rewrite everything, like reinvent the wheel. I'm just gonna, for now, use the listener handle provided by the Kira API, and that's gonna be my API for working with listeners. For now, everything is just rough, and it's just to get something up and running. Okay, so we don't want to manage listeners. We don't want to own them. We want to hand over the listener handle to the user because if we look here and we do add listener, which is using the add listener on the audio manager from Kira. Add listener. You could see that it returns a listener handle. If we look at the listener handle, you'll see that we could do a few things here, like get the listener ID, which we don't probably won't use, and then set position, set orientation, and drop. Yeah, so this is what we'll be giving to the user, and they'll be taking ownership of listeners for now. Yeah, over here. When a listener handle is dropped, the corresponding listener will be removed. Cool. So we don't have to manage this. Okay, so let's change our code. Let's just do that instead. Mm, resource limit reach. let's see where that is. Oh, there we go. No need to do that. Oh. Cool. Always feels bad deleting old code when you like it, but no need to be sentimental. We don't need that. We did too much. Cool. That should be that. And then the actual API that our users see, I put over here an API. So I just wrap whatever our internal state is in the engine by borrowing a reference to the inner state. And then I provide a publicly safe API for the users of our game engine to use. And over here I can just do that. That should be good. So this is the audio we provide in our engine currently. It's very basic, but you know, it feels nice keeping things simple, especially if you're just starting out. Load sound, unload sound, create listener, play sound. Cool. So you can manage what sounds are currently in memory, and obviously you can also manage your users have to take ownership of the listeners and sounds, but we take ownership of the sound data. So users can't unexpectedly, like they don't get to manage the actual data load in memory for now. Yeah. Cool, let's try this out in our example. So I do have an example going. Example game. Currently the game just spawns like 10,000 sprite of the same sprite. And all the sprites turn to look at your mouse, as you can see here. As you can also see, we haven't done we don't properly handle like the screen size the window changing size, and like how we scale with the resolution changes, like, and also the aspect ratio gets messed up and all that stuff. But it works. We can render sprites. Here's 10,000 sprites being rendered. They all look at the mouse. Just so you can see it's like working live. And we get 400 FPS by doing that, which somehow feels like it's lower than it should be, but I don't know. And cool. So what we want to do now is try to play a sound. So the way that you make a game using the game engine is you simply implement the game trait for whatever your game is. We'll just call this game example game, but you could call it whatever you want. And then you have inside the game trait, you have a bunch of functions you could implement. And that is how our game engine runs your game. Which is pretty nice because then the engine is in control of all the important stuff, like the the main state of the application running, because the application needs to run in different ways on different platforms, and it's not something we want to expect our user to understand. Um, so we simply hook into the user's code when certain events happen, and they can implement whatever they want in those hooks, and in that way write the game. And hopefully that's a really simple way to get like a front end up and running for your own game. And if they understand the idea of creating their game in a headless like way and having temporary glue code between that and this engine, it should have absolutely no effect on the way they architect the game and write like the structure of their code. Yeah, it should have no impact on the architecture of the game. But that's something we need to explain, is like how to use this properly. Can worry about that later. So yeah, we want to currently we every frame we call pre-render on the user's game, and we pass through a context that has this contains basically the whole API for how the user can interact with the game engine at this point in time, like right before rendering a frame. Everything you can safely do is encapsulated exactly here in this object. And this object is very simple. It's the same as the audio API. It Don't worry about what it says in here. The idea is that it just contains a reference to the inner state of the engine and safely mutates that state and wraps it in a API for the user. And this is how we control what the user can do at what point in time with our engine, um, so they don't accidentally break stuff. Yeah. And so far we have some stuff going on here. Users can do texture loading, can do some things like get the window size, I think. This is old code for working with sprites. Actually don't need that anymore. I'll clean that up another time. But yeah, so what we want to do is we want to add audio, our audio API here as well. So audio, and then we have audio API, audio API. That also takes a inner state. And then over here, when we create this context from within our engine and pass it through to the user's code, we also want to pass in our audio. We want to create a new audio API, and to do that, we need to pass in our audio engine audio. Call this audio engine or whatever. Make that public. And then instead of wrapping it over here inside this implementation, we could just expose it so the user can do .audio and then get access to all the audio features. That way we don't have to write out all the then to wrap the API a third time. Should be good. Cool. Then we'll have errors where we actually create this. Let's see. What's that? What the? Okay, here we're inside our engine and we're actually... So the engine takes ownership of your game. So you create a new instance of the engine. You pass through your game over here. And then obviously this is just like a winit instance that handles window events for us. And when we get a event to redraw the window, we also call pre-render on the user's game. And that's where we pass through this context. And to do that, we want to pass through an instance of the audio API, but we don't have audio state at all yet, so let's do that. Cool. Okay, so we create our audio state inside our engine instance. There shouldn't be any weird setup we need to do. It's just all basically just an empty audio manager from Kira. And we track loaded sound datas and listeners in here. But we probably don't need to track listeners because we let the user own listeners. There we go. Yeah, audio manager never used. That's fine. Cool. And then back in our engine, create a new audio state. And then we want to pass through we want to wrap that state in that audio API and pass that through to the user. So that's exactly what we're going to do here. We'll do create audio audio API. There we go. Then we'll do self.audio state. There we go. Cool. Yeah, no errors. That should be good. So we'll go to our game. And now, if we go to where we do our render update, I'll have to come up with better names for this stuff. Yeah, once I actually know what architecture I'm going for, but for now, render update is just called pre-render. And over here, we wanna load and play a sound. So we don't have a start callback yet, which kind of like you would expect out of a game engine where you have like before the first frame of the game, you run some logic to load assets and stuff like that. So we don't have that yet. So what I'm gonna do is just improvise and go to our state and add when the frame count is still 0, if the frame count is 0, then we're gonna load a sound. And then after that, we're just gonna play it like every 1,000 frames or every 10,000 frames. And that's just kind of like a quick way to experiment with our audio and see if it works. Cool, I need an audio file. Quickly download something, I guess. Or I could just record. Do I have Audacity? Yeah, I do. Yeah, I'm good. Okay, for you guys, I have audio paused because I have some copyrighted sound music playing in the background. I'll just pause my music while we're doing this. Okay, so you guys should be able to hear desktop audio. Cool, we got a sound effect. Wow. Let's export this and we'll just export it to projects, game front end, assets. We'll create a new file here called audio. And we'll just call it finger click .wave. We'll change that to OGG. It seems like this thing takes OGG. Maybe it takes any sound file. I don't know. OGG Vorbis file. Cool. What's going on here, bro? Cancel. Maybe that worked. Let's just see. Audio. No items. Yeah, that did not work. Oh. There we go. Yeah, it seems like it's the correct format. Cool. Let's go back to our project. And we'll close this. Nah, no need to save that. Let's just put our Git on window number 4 and over here. I'll just keep my file manager open. Cool. Okay, so we wanna, how do we load stuff? So we wanna call .audio.load sound and then pass in a path. And it should be in assets audio finger click.ogg. So we have, yeah, that returns an error if the file doesn't get loaded. So let's just install the audio data ID as well. Autocomplete's not working because I broke the abstract syntax tree or something like that with this code over here. Let's try again. What? Great. Why isn't this working? Oh, it's not create. This is a example. It's using, yeah, we need to specify up here that we want to use audio. Let's just use everything, dude. Boom. Actually, let's be specific. I want to use sound data ID and AP, and yeah, that's it. That should be it, actually. Cool. So sound data ID. Cool. So if let okay sound data ID self we still haven't done that. Go starts out as none. That's right. There we go. Cool, that should load the sound. Let's see if we get an error when we run. I think that worked. I think that worked. Let's go. Cool. So okay, and if sub.frame count modulo. Let's play this every 1,000 frames. Let's make it every 2,000 frames. Because we get like 400 FPS, so that should be like, let's say 500 FPS. So we want to play it every 4 seconds. We want to do that every 2,000 frames. So every 2,000 frames exactly, then for 1 frame we want to start playing a sound. So we'll do audio play sound self dot we also want to make sure we have the sound loaded. So this returns a sound. Wait, what's going on here? cannot move out of, yeah, okay, I don't want to move out of that. Let's just do, take a reference, should be good. Yo, what? Just implement clone for our sound data ID. Derive. Debug. Copy clone. There we go. Should be good, right? Also, yeah. Cool, and if that's successful, that returns a sound handle. Now we won't use it, we'll just see if we actually hear anything play. Oh, I hope this works. Yo! We've got audio. Ways. That was easy. Alright, well, that's awesome, man. Now just for funsies, let's also say sound handle. Sound. See, now this is where it would be annoying for the user. They'd have to actually depend on the Kira library as well, just to reference the sound handle type. So, wait, what's the exact types that we return? Kira sound, static sound handle. Yeah, that's a lot. So I could just re-export this and then have that come out from the engine, but at the same time, I don't want to take ownership of that type. They'll just, for now, you'll just have to also use the Cura sound library. Let's see, does it actually show the return type? New play sound for the user. Yeah, so they'll be able to see that they need to use that they need to use that. It's kind of a a dumb way to a bad thing for them, but it's fine for now. Cool. So we store a sound handle. Should be some, and we'll change this to self.sound handle. If let's, does this return? Result, yeah, of course. Cool. Then we should have an error up here because we haven't set that to be initiated as none. Cool. Okay, so we play that sound handle. This will replace any sound handle that's currently inside of here, but that's okay. We'll just do change latest finger click sound instances volume. Let's say position. Nah, this is too much. It's too much. Yeah, we'll just do. Oh, we won't even store it. We'll just use it up here. There we go. Actually, um, what? How do I change the position? I just wanted to randomly like play the sound on the left or the right, and see what that sounds like. Let's do something else. Set loop region. Let's do 0 dot. Let's open our sound again in OBS. I mean Audacity. Just for funsies. Yes. Oh, what am I doing? I need to go to the actual project. Cool, so from 0.7 to 0.9, let's just play that on repeat. 0.7, 0.9, let's see. Cool, that should just play, that should just loop that over and over. See if that works. Yo, it works. That's amazing. Oh, now we're looping every single one. Okay. Set loop region. Can we set it to not loop just for fun? Loop region. Right. Okay, that's enough fun. It sounds all working. That's pretty good. It was pretty easy. That's pretty good though. We have that working. I'll remove some of the code I'm using. Just remove the sound handle for now over here. And yeah. Cool, we've got sounds playing. So we can draw sprites and we can play some sounds. Later on, I'll worry about changing, like, because I'm gonna redo sound completely. This is just temporary. But later on, I'll worry about getting positioning working as well, because it seems like I don't even want to like use the time on it, but um, for some reason I couldn't set the position of the sound directly through the sound handle. But yeah, audio manager. Okay, so let's save that. So what did we do? We add audio stick. Cool. Um, that's awesome. So we've got, so far in the engine, we've got some, we can render sprites and scale them and rotate them and change their position. Can load and save, load and unload textures. And now we have audio. You can load and unload audio and you can play audio. Yeah. So, oh, excuse me. So next, I think that I'm gonna leave it there for now. Next stream, I will try to I'll try to get to UI, and I do already have a tower defense that I'm working on in Godot, but the actual tower defense code is written in Rust. I want to migrate that over to this as well. I was thinking of maybe starting to do that this stream, but um, I have something going on. I probably need to get off now. But thank you so much to anyone who watches. God bless and all the best. And yeah, hopefully next stream we can get to working on. We just want to add eGUI, and then hopefully we have enough features to start working on a tower defense using our game engine. And I'm probably also gonna have to clean up some code. Like earlier I saw some legacy code for, what am I doing, dude? Go to word AP. Sorry, I'm still practicing some new keybinds that I'm trying to use. So I saw some old stuff here for how to update sprites, but this is legacy code. It shouldn't exist anymore. I'll remove that next time. But yeah, thanks for watching, everyone. Hopefully we have we have a bit more going on next stream, and I'll catch you all then. And yeah, see you guys. All the best.